So guys, let's revise what we have done so far. So we have created this volatile long unpadded. What we want to do here is that we only have this long value, one value, and our idea is that we will create multiple objects of this, and so that we have this condition here, this condition of having like multiple threads trying to manipulate this long value in that unpadded class and multiple times, and we will see that whether we just based on this logic we will try to see that by having so many iterations so many times, it will be actually eventually having this cache line corrupted because of fault sharing, and it will the performance will go down tremendously. So this is what we want to do. That's why we have only got one variable here inside this volatile long unpadded. Unpadded means that I'm just using a single value here long in this object. It would be only like 8 bytes long. So if we have got multiple 8 bytes, it means that it is very much possible that this long value for multiple objects would be in the same cache line, because the same cache line can be of 64 bytes or 128 bytes. Okay, so in the test, and then we created like the number of threads as 4, iterations as 100 millions. And this is the array that we will be creating. And this array, we are creating 4 objects of it. So this is where we suspect that, for example, this object and this object having the same cache line for that long value. And then in the unit test, let me make some change here. It should be 1. And because if it's 0, there would be, this will not proceed. So at least we start with the 1 thread to 4 thread. So in this for loop here, so what our idea is that there are 4 threads now, and for the 4 threads we would be creating. Then, for example, for the first thread it would be only 1 thread. Then we'll see that how the performance goes with only 1 thread, and then because for 1 thread we suspect that there would be no fault sharing, because the same thread would be doing it either for 1 or the other one. So the fault sharing only happens when there are multiple threads here which are trying to manipulate the objects in the same cache line. If there's only 1 thread, the fault sharing should not happen. So the first iteration should be fast, and this is what we are measuring here. And the threads are just doing a very simple thing, that they are trying to invoke this value method and then print it like 100 million times. Just set the value 100 million times. This is what it is doing in this run method. So that by having so many invocation of that, we suspect that it will be appearing in the fault sharing. Okay, so this is what we are doing here. We start it and then we join it, and then finally we check the time elapsed. So this is where we will measure the performance. And after this, we just print out that this is the number of threads and total time taken. Okay, so we have suspected for the 1 thread it would be fast, but as the number of threads increase and the number of objects also increase, in that case, it would be having a fault sharing. So enough said that, let's run it. And let's run it multiple times and see. And we'll try to store it somewhere, that what is the time taken. So let's run it. So there would be an output soon. So, okay. Number of 1 threads, total time taken is 1548. For 2, it's almost double now, as you can see. For 3 is okay. There's some performance, little bit improvement, but still it is increasing in an order. It's not like having a proper any performance improvement. So it appears that there has been some fault sharing. But let me copy this and let's run it like at least 2 times more. I'll just copy it in a notepad here and let's run it 2 times. So I have run it 3 times. As we can see that each time it is, as the number of threads are increasing, this fault sharing happen, and that's why the performance is getting worse and worse. So every time after 4 threads, it's 4846, and in the third run, it was even worse. It just jumped from 2765 to 4086, and then 5165 milliseconds. So this is the first part of the problem we just covered, in which we were able to demonstrate this fault sharing in Java. Again, what we are doing is, here we are trying to change the values here for this unpadded long, and because there are multiple threads involved and there are 4 objects already created here, so one of the threads which is manipulating the cache line, say for example we have got this value for one for the first object, and this is for the second object, and it's relying on the same cache line. If one thread is manipulating this A, Then thread 2, even though it hasn't done anything for B, it will invalidate the whole cache, and then it will have a fault sharing, and then it will try to reflush everything from the main memory or whatever, or the L3 cache, whatever. So this is the demonstration for fault sharing. Now we will change the same program, and then we will resolve this fault sharing, and this is our topic for the next video. So let's see you all in the next video. We'll resolve this fault sharing and improve the performance.